Hello everyone and welcome to EvolkAI, a machine learning community for machine learning enthusiasts. Now today we will be learning about linear discriminant analysis. Okay, linear discriminant analysis, also known as LDA, is a technique used in machine learning and statistics for dimensionality reduction and classification. Let's imagine you have a group of students and you want to find a way to understand the difference between high achieving students and low achieving students based on their scores in different subjects. Now, in LDA, the goal is to find a linear combination of students' scores that best separates the high achieving students from the low achieving students. It does this by maximizing the separation between the mean of two groups while minimizing the variations within each group. To achieve this, LDA calculates the means and variance of the scores for each subject, separating for the high achieving and low achieving students. Then it finds a directions in the data that maximizes the separation between these two groups. This direction is called the discriminant axis or linear discriminant. By projecting the scores of the students onto this axis, LDA reduces the dimensionality of the data from multiple subjects to a single value. Once the linear discriminant is determined, LDA can be used for classification. For a new student, LDA projects their score onto the discriminant axis. If the projected value is closer to the high achieving group's mean, the student is classified as a high achiever. If it is closer to the low achieving student's mean, the student is classified as a low achiever. So LDA is a technique that finds a direction in the data that maximizes the separation between different groups. In our example, it helps us to understand the difference between high achieving and low achieving students based on their subject scores. By reducing the dimensionality and projecting new data onto the discriminant axis, LDA can also be used for classification. Okay, so now moving to the practical part. Okay, so now first we will start by importing the pandas library, and we will read the dataset using the read CSV function, and we will get all the data information using the info function. Then we will assign all the columns that we have to take from the user and store it in features variable, and the prediction class will be predicting column will be stored in prediction class variable. So and their values will be stored in X, and for the features, and for prediction class the values will be stored in Y. X will have all the data that our user will give us as the input, and Y that it will get as output from the machine learning model. Now this is the training and testing part. Here we have to train here we have to split the data into training and testing part. So here we have assigned test size as 0.30, which is an ideal, as we have already discussed in our earlier videos, that the testing part should always be less and training part should always be more. So here the training and testing part is divided into the ratio of 7:3. That is 70% is the training part and 30% is the training part. More that a model will be trained, more accurately it will predict the results. Okay, so now here we will check the shapes of the data to check if the test split has done its work correctly or not. Okay, so now we have reached the most important part. Now here we will import linear discriminant analysis from sklearn discriminant analysis library, and will assign this classifier to a CLF variable. Now we will fit the training data uh, or in the model or the classifier. Now we will predict on the X test data using the model and store the results in the ypred variable. Now we will import metrics from sklearn, and using the accuracy score we will calculate the accuracy of the model using ytest and ypred variables. Now for every time ytest and ypred being same, the accuracy will increase, and for the other times the accuracy will decrease. So for this model we have gained an accuracy of 97.77. That is that is quite good. That is the I think the maximum we have achieved yet, except for 100. Okay, so now moving to the Visual Studios. For what we have done till now, we will just see it practically, and then we will conclude the video. Okay, so now we have come to our Visual Studios. Now first we will start by importing the pandas library. So I'll just quickly run all the snippets. Now, uh, we will import pandas library, and we will use read CSV function of pandas library to read the data set that is in CSV format. Then using the info function, we will take out all the informations of the data set, that is how many columns it has, what are the data entries, if the data set has null values or not, or the data types and their memory usage. Now we will define two variables, that is features and prediction class. So features will have all the column names that a user will give will be asked as input, and the prediction class will be the one that the model will calculate on the basis of the prediction class and will give to the user. Now their values we will be taking in x and y. So x will have all the values of the feature class, and y will have all the values of the prediction class. Now from sklearn.model selection, we will import train test split, and we will split the data into the ratio of 70:30, uh, and will separate the data in x train, x test, y train, and y test, and we will print to check if the split has been done properly or not. Now here we can see that the training is 105 and the testing is 45. So if we can say that the training and testing has been done in a proper way, and uh, since the data training data is more and the testing data is less. Now from sklearn.discriminant analysis, we will import linear discriminant analysis. Linear discriminant analysis follows some mathematical formulas to calculate to calculate to function on a model, to function the model, we can say. And now we will fit this model with the training data, and when the data is trained using this trained model, we will predict on x test data and store results in widespread variable. Now from sklearn we will import metrics, and will using the accuracy score, we will try to calculate the accuracy using y-test and y-pred variables. Now every time the y-test and y-pred variables being same, the accuracy will increase, and the other times the accuracy will decrease. So for this particular algorithm or this particular model, the accuracy we have achieved is 95.55, which is one of the best ones. So this was it. Now we will be going back to the conclusion part, and we'll conclude the video. Okay, so now we have reached the conclusion part of this video. Now, for the conclusion, LDA, that is linear discriminant analysis, is widely used algorithm in various fields, including pattern recognition, face recognition, text classification. LDA offers the advantage of dimensionality reduction, allowing for efficient representation of data while preserving discriminative information. It can handle multi-class classification problems and works well with balanced dataset. LDA also provides insights into the discriminative features by evaluating the importance of each features in classification process. However, LDA has some limitations. It assumes that the data follows a Gaussian distribution within each class and the class covariants are equal. Violation of these assumptions can affect the algorithm's performance. LDA may not perform well with imbalanced dataset, or when there are overlapping classes. It also assumes linearity between the features and the class boundaries, limiting its effectiveness in capturing non-linear relationships. So this was pretty much it for the video. I hope you liked it. Thank you for watching, and happy learning.